Hello everyone. In today's video, we're going to talk about exponential rates of change. I'm going to put the questions we're doing together today on the screen so I don't have to write them and so I have more room to do some work here. So the first question I'm going to do is from my paper. It's number 1. That's just more for me than it is for you. So it says, given the following exponential function, identify whether the change represents growth or decay, and determine the percentage rate of the increase or decrease. So this equation that they give us is already set up to answer this question. Remember, when you're dealing with exponential growth or decay, the number out front, right after the equal sign, is the initial value. And the exponent is usually how many days, weeks, months, how often, right? So we're just going to label that as time. And the important part here is right in the parentheses. That is the rate of growth or decay, but it's disguised. And the reason I say it's disguised is, remember, growth and decay is written like that, actually. 1 plus or minus the rate. All right, so we don't want to know this number. We want to know that number. And this number has already been taken away from 1, or it's already been added to 1. So we have to kind of undo that work. Okay? So what is the value of r that would make that number true? Well, let's write it out. 1 plus r equals 0.866. So let's solve for r. Let's do minus 1 to both sides. Then we get the rate is equal to, when I subtract that, I get 0.134. It's actually going to be negative, right? 0.866 minus 1 is negative 0.134. And what does that mean in this context? That means that our rate is 13.4%. And instead of making a negative, let's translate what that word negative means. It means decay. It's a decrease, or it's a decay, or it's a reduction by 13.4%. A really fast indicator of that would be the fact that this was below 1. As soon as you see that that's below 1, you know that we're decaying. And to figure out how much we're decaying by, we do 1 plus or minus that number that we didn't get given. Okay? Let's try another one. Let's try question number 7 here in my paper. Question number 7 is the same setup. It says y equals 4 raised to the negative 2x. Now there's a problem with this setup, and that's our exponent isn't just x, it's negative 2x. We can't answer this question if the exponent is anything other than x. So we're going to deal with that too by just using it. What is 4 to the negative 2? We're going to rewrite it like this. 4 to the negative 2 to the x. When exponents are multiplying, you can break them up and only do part of them, as long as you leave the other one behind still as an exponent. And why would we want to do that? Well, now I could do that on my calculator. 4 to the negative second is 0.0625. So y equals 0.0625 raised to the x. Hey, now this is set up for me to answer the question. I know that there's not a number out front, but that's okay. The question is asking, what is the rate of decay? Well, it's 1 plus or minus the rate. Turned out to be that number. And when I subtract both sides by 1 to get the rate, I'm going to change this to be just minus because we know it was decay. And when we do that, we get 0.0625 minus 1. We get negative 0.9375. And what that means is this whole problem in disguise was a 93.75% decay. And actually, this question wanted it to the nearest tenth. So that would be a 93.8% decay. So this question wanted to know how much were we decaying by, and we had to do a little bit of work. Remember, the exponent has to be just x. You can't answer the question unless its exponent is just x and the number in parentheses is ready to be simplified or solved. All right, let's jump to the next one on my list here. That's number 11. Number 11, I shouldn't have to write anything. I can just say the function represents the change in quantity over t days. What does the constant 0.998 reveal about the rate of change of the quantity? Well, the 0.998 means that we're decaying because, again, it's lower than 1. And how much is it decaying by? It's not decaying by 0.998. It's not decaying by 99%. It's decaying by 1 minus the rate. And the answer to that problem is 0.998. That means that the rate of decay is 0.2%, or about 0.002, now as a percent. And what is the time this is happening? Notice that exponent has a divided by 7. So it says the percent, it says the t represents days. And if we divide the t in this problem by 7, that's not going to measure how many days anymore. That's going to measure how many weeks. So the answer to this one is that it's decaying at a rate of 0.2% every week. Let's do the one right below it on my paper. Let's talk about that one. What does the constant 0.7 in this question reveal about the rate? This one's also decaying because 0.7 is less than 1. That means it's a 30% decay, right? The amount of decay is never in the parentheses. You have to do a little bit of work. In this case, you need to do 1 minus 0.7, and that'll get you 0.3. So this is a 30% decay, and because the t is just a plain old t, that means that this is happening every day. T was measuring days, and nothing happened to the t in the exponent, so it's just going to stay as days. All right, let's take a look at the next one. This one's a really long one, a lot of writing. I'm glad I didn't have to write it on the board. Element X is a radioactive isotope such that its mass decreases by 24% each year. If an experiment starts out with 700 grams of element X, write a function to represent the mass of a sample after t years, where the monthly rate of change can be found from the constant in the function. Round out coefficients in the function to 4 decimal places. Also, determine the percentage rate of change per month to the nearest hundredth of a percent. This one's going to be a lot of writing, so let me make sure I have enough room here. Let me erase the board. I'll be right back. Magic, I'm back. All right, well, let's start with the formula for this problem. The formula for this is, good mark. The formula for this is y equals a parenthesis 1 plus or minus r to the n. I've got that letter wrong. Let's make it consistent. They usually use that as p. You usually use that as a. So anyway, this question told us that we start with 700, so P is 700. And they told us the rate is decreasing by 24%. That means it's 0.24, and now I can get rid of this plus. And now we just know that it's a minus. And we don't know how long, let's be consistent and make that T. We don't know how long this is going to be going on. So that would be the setup for this question. However, they want more from us. They say that t represents years, and they want this to be monthly. So how could I make this monthly? Well, I need to take the time that we think is going to happen, and I need to raise it to the 12. I need to multiply it by 12. Because if something happens for 2 years, this question's supposed to be in months, not years. I need to multiply the number of years that I know it's happening by 12. So I need to multiply the exponent by 12. That's going to convert the number of years that we were using into the number of months we were using. Now you should say to yourself, well, that's a problem. You can't just change the exponent. And that's true. We can't just change the exponent. So I'm going to scoot it over because we need more room here. you can't just change the exponent without balancing it out. And how are we going to balance that out? Well, what we're going to do, first of all, is we're going to actually answer this question. This is 0.76. And if I just introduce a 12 into the exponent, I have to balance that out by putting a 1 over 12 on that rate. Right? This formula was set up for something that's happening yearly. And if I just throw a 12 in there because I want it to be monthly, I can't just do that. That's going to change all the numbers in the problem. So to balance that out, I'm going to put a 1/12 here. And the reason why that's okay is what happens when you raise an exponent to an exponent? Well, this 12 and this 1/12 will multiply by each other, and we'll end up with just 1, which means we'll just end up with t. So that's going to change our rate, right? Because this is 76% decay over the period of a year, but they want to know how much is it decaying by month. So we can do that just by doing 0.76 to the 1/12 power. And we end up getting 0.9774. And now, what does that mean? That means how much is it growing or decaying by every month? It's not decaying by 97%. It's decaying by 1 minus 0.9774. It's decaying by 0.02261. All right, because remember, this number already had the 1 subtracted or added to it, so we need to take that 1 away. So that means the rate of decay here is, let's say, times 100, and let's round to the nearest 100th, 2.26%. So this question was asking two things. What is the equation? And here it is. Right, this is technically the equation, and this is technically the equation, but this is the equation simplified. This factors in the fact that we could do that math problem and be at that. And they also wanted to know what is the rate. So this is decaying at a rate of 76% per year, but it's decaying at a rate of 2.26% per month. So I know these questions are tough, and I'm sure you're going to have some questions. So if you have some questions, ask me or put it in the comments, and I'll see what I can do. All right, that's it for today. Thanks for watching.